Good morning, students. Good morning. So, organic chemistry. Basic concepts. Okay. So, 3 days, right? 3 days holidays were there, right? All of you have forgotten. I have to introduce myself. Now, simply I was kidding. So we were discussing about basic concepts of organic chemistry, right? So in that case, in the last class we were discussing about the IUPAC nomenclature. If you remember, we were talking about IUPAC nomenclature, right? So that's what we were discussing in the last class. We were talking about the IUPAC nomenclature. So there we have discussed about the linear molecules and the branched molecules. In this case, when it comes to IUPAC nomenclature, we have discussed with some of the examples related to linear molecules or non-cyclic molecules. All of you will agree? Okay. Now today we are going to discuss about cyclic structure. So today we have to discuss about the cyclic structure. When I am talking about IUPAC nomenclature, some important thing we should follow. Which is that one? That one is a selection of main chain. Selection of main chain. That will be the first rule. First step, what we have to do. First we have to select main chain. Okay, highest number of carbon should be there. Then we have to discuss about least sum rule. We have to, based on the least sum rule, we have to number the branches. We have to number the branches. And when we are going with the least sum rule, with respect to functional groups, we have to follow priority, and we should see which one will be used as a prefix and which one will be used as the suffix. Now when it comes to prefix, priority is based on the alphabets. When it comes to prefix, it will be based on the alphabets. But when it comes to suffix, we have the least, where name of the molecule should be ended up with those functional groups. All of you will agree? Right? So these are some of the rules which we have to follow. Fine? When it comes to cyclic structure, now first we will go with non-aromatic compound. Cyclic non-aromatic compounds. So first one, it is with respect to non-aromatic compounds. Okay? So in that way, first one I will write like this. Right? So this is the molecule. What should be the name of this molecule? What should be the name of this molecule? This is the molecule, what I have written. We have to name this molecule. Okay? How to name this molecule? Yes, least number rule. Gaurish has written least sum rule or least number rule. Yes. So if I see longest carbon or largest carbon with respect to this molecule, which is a cyclohexane. 1, 2, 3, 4, 5, 6. It is the cyclohexane having substituent of methyl and ethyl group. What I mean to tell you is this is a line structure. This is a line structure. If I want to go with regular one, then I can mention like this. Whatever I have written, it is a cyclic structure. Okay, CH3. That means CH. So here CH3. That means CH. So this is the molecule. This is the line structure. This is the line structure of that particular molecule. So we have two substituents here. So this is a cyclohexane where we have two substituents, one as ethyl group, and another one as methyl group. Another one as methyl group. So what we have to do? Both are alkyl group which has been substituted. Both are alkyl groups which are substituted. So what we can do? So we have to go for alphabets. Priority should be given with respect to alphabets because both are alkyl group. So we have to follow least in some rule, no doubt. Okay. So here instead of telling as branches, we can call it as substituents. So we have to go with least some rule, no doubt. And alphabet should be having the preference. So can any one of you tell me name of the molecule? Can anyone? Name of the molecule. So we have both as alkyl group. I have written both, line structure also, a normal structure also. So 1 methyl, 2 ethyl, cyclohexane. So that's what Rohan is telling. All of you will agree with that? Or any other name? No, Rohan, we cannot accept that one because alphabetically E comes first compared to M. So methyl, M is there. Ethyl, E is there. So therefore, I should number in such a way that if I start from here, alphabetically this one will come first. So 1, 2, 3, 4. So 1, 2, 3, 4, 5 and 6. So that's where we have the numbering. Right? So I will start from ethyl group because E comes first. Okay? So Shashank, it's not 2 ethyl. So don't worry, don't think that whichever comes here first on the top, that should be written. No. Same molecule I can write like this also. Same molecule I can write like this also. One and all same. They are not different. One and all same it is. Okay, any direction we can write, no problem. Okay, na? So don't think that since this one is present here, so 1, 2, 3, no. We have to give priority based on the alphabet. So therefore, I can mention this one as 1 ethyl. 1 ethyl. So 2 methyl. 2 methyl. Cyclohexane. Cyclohexane. All of you have understood? So 1 ethyl, 2 methyl, cyclohexane. Yes, Gauri. Now, for example, same molecule, I will give the number 1 to ethyl group. Observe here carefully. If I am writing the same molecule and numbering will be like this. Okay, so 1, 2, 3, 4, 5, 6. Right? People thinking that clockwise. So we have to go with clockwise, not anti-clockwise. This is wrong. Because if I go like this, substituent I am getting at 1 and 6, that is 7. But here 1 and 2, that is 3, least sum rule. Least sum rule. So this is the proper one, this is wrong. If I cannot number like this, this is the wrong one, because least sum rule we have to follow with respect to branches also and with respect to substituents also. When I am talking about a cyclic structure, we can call it as substituents. All of you have understood? Any doubt? So we have taken parental molecule as cyclohexane because 6 carbons are there in its structure compared to 2 with respect to ethyl and 1 with respect to methyl. All of you will agree? Any doubts? Okay? So that's where we have a non-aromatic cyclic structure. A non-aromatic, a cyclic structure. Next one, another molecule I will write. So this is the molecule. This is the molecule. Now what we have to do? This is the molecule. So we can take it as parental molecule as heptane because we have 7 carbon. 4, 5, 6, 7. Since we have the 7 carbon, this one we can take it as a main chain. And to that we have the cyclohexyl derivative. Okay? So therefore we can write it as 1 cyclohexyl heptane. 1 cyclohexyl heptane. Okay, all of you have understood? So 1 cyclohexyl heptane, Gauri. Okay now? So that's why we have the name of the molecule. Even another name, you can use it as 1 heptyl cyclohexane. People will call 1 heptyl cyclohexane. But this will be the correct one. 1 cyclohexyl heptane. But that doesn't mean that 1 heptyl cyclohexane is wrong. Some people they will use that one also. But this will be longest carbon we have selected, 7 carbon, as the parental molecule. That is heptane. Okay? And to that at first carbon there is a cyclohexane molecule. Substituent should get the least number. So therefore numbering should be done from here. Right? So now if I want to write the condensed structure, then I can write it as CH2 5 times CH3. This is much more condensed structure. Whatever I have written, that is actually a condensed structure only. But whatever down I have written, it is much more condensed structure. Okay? Now if I want to write the line structure, then it will be okay, na? 1, 2, 3, 4, 5, 6, 7, 8. Only 7, huh? So 1, 2, 3, 4, 5, 6, 7. Only this much. This will be the molecule. All of you have understood? So this will be the molecule, 1 cyclohexyl heptane. So which can be used as a line structure. This can be used as a line structure for this molecule. All of you got the point? Any doubts? Any doubts with regard to this? So this this is with respect to a cyclic structure which is non-aromatic and which is not having any of the unsaturation. Now we will go with the cyclic structure, non-aromatic but which is having unsaturation. Naturally there should be presence of double bond. Triple bond cannot be present. A cyclic structure we have to discuss about the double bond. Okay. So now when I am talking about the double bond, one of the molecule I will take. Okay. Now this is the line structure. This is the line structure. So can any one of you tell me what is the parental molecule or which is the parental molecule? Just tell me the name, parental molecule. Which is called as parental molecule? Large number of carbon among that. That will be considered as a parental molecule. Can anyone? Just tell me the parental molecule, nothing else. Okay, whatever I have written, it is a line structure. So I will write it as okay. There is a double bond. So this is the regular structure. Line structure, regular structure. Okay, it's a butane. Now if people are writing, it's a butane. Ashish, it cannot be a heptane. It's a butane. Because you cannot consider the whole set of carbon. No. Here it is a cyclic structure. So to that there is a substituent. To that there is a alkyl substituent. Now please remember that since we are talking about cyclic structure, now those carbons which are involved in the unsaturation should get the least number. Those carbon which is having or which are involved in the unsaturation should get the least number. That means I will number this one as 1, 2, 3, 4. Okay. So I will number this one as 1, 2, 3, 4 like that, anti-clockwise. Because if I number like this 1, 2, 3, 4, that means this carbon which is also involved in the unsaturation, I am giving largest number. That should not be done. So those carbons which are involved in the unsaturation should get the least number. Okay. Now, due to that, the name of the molecule should be 1, 4, 4. That means 1 methyl, then 4 methyl, 4 methyl. That means trimethyl. Then, what is the parental molecule? Cyclobutene. Trimethyl cyclobutene. It will be written as butene, cyclobutene. All of you have understood? All of you have understood? Any doubts? Okay? Fine. So this is with respect to non-aromatic Non-aromatic cyclic compounds. Okay. So now there we have discussed about unsaturation and all. Now we will come to the cyclic structure with aromatic compounds. Cyclic structure with aromatic compounds. Aromatic compounds. ಹಾಗಾದರೆ one thing you should remember that we have two molecules which will be used as a substituent. Now we have one molecule as this one, which will be attached to a parental molecule or can be a main chain. Okay, we will discuss it later. Main chain. Now if you are considering this one as a substituent, please remember, if you are considering this one as a substituent for a main chain, if you are considering this one as a substituent for a main chain, then we can call it as phenyl. We can call it as phenyl groups. Phenyl groups. If I am considering this one as a parental chain or parental molecule, main chain molecule, then I will call it as benzene. Okay. So when this particular molecule, that means when I am telling it as a phenyl, I am talking about this part. It will be considered as a phenyl. If I talk about only this part, then I will call it as a benzene. All of you have understood? So benzene, when I am calling or using it as a parental molecule, but when I am using it as a derivative or substituent, then I can call it as phenyl group. I can call it as phenyl group. So don't get confused. I can call it as phenyl group. So why I am telling this one? Because I have another molecule where if I consider this one as a substituent, if I am considering this one as a substituent, then I can call it as benzyl. Okay, then I can call this one as a benzyl. Okay, now if I consider this one as a parental molecule, it can be go with toluene. All of you have got my point? So benzyl, when it is used as a substituent, parental molecule can be a toluene. Where CH3, toluene. CH3 with benzene, it is actually called as toluene, a common name, which is also considered as a IUPAC name. But when it comes to here, we have the phenyl and benzene. Any doubts? Don't get confused between benzyl group and phenyl group. Phenyl group where only benzene ring it will be there, which will be used as a substituent. Then it is called as phenyl. And this is where we have the benzyl. Any doubts in this? Okay? Any doubts? Okay, fine. So in that case, before going for the molecules, some of the important molecules with respect to aromatic compound, that is benzenoid aromatic compound, I will discuss. One is here, that is called as toluene. Then we have another molecule, OCH3. This one is called as anisole. Then we have another substituent, that is NH2. Then it is called as aniline. Please remember all these things. We have then phenol. OH. These are some of the compound you will come across. So phenol, aniline. What is aniline? aniline can be called as aminobenzene. Aminobenzene. Or we can use the word as benzenamine. So, benzenamine. We can use the word benzenamine, where amine group is the substitute, means functional. Benzenamine. Right? Since amine group, it is a functional group which will be used as a suffix, you can go with this benzenamine or aniline, etc. Okay? This one we can call it as benzenol. This one we can call it as benzenol or hydroxybenzene or hydroxybenzene. Since OH, we can use it as suffix. We can use benzenol or phenol. Benzenol or phenol. Same way, when it comes to anisole, it will be called as methoxybenzene. It can be called as methoxybenzene. Alkoxy group, if you remember, I have discussed about OR, alkoxy, same thing. Methoxybenzene. Same way, here we can call it as methylbenzene. We can call it as methylbenzene. If you observe, wherever amine group is there, we can use that one as a suffix, -ene, suffix. Whenever OH group is there, we can use it as OL, suffix, benzenol or phenol. But whenever we have alkoxy group, it will be used as a prefix, methoxybenzene. Alkyl group, methylbenzene. All of you have understood? But toluene is also accepted. Anisole is also accepted, even with respect to IUPAC naming also. Okay? Anisole, aniline, all of them they are accepted as the IUPAC name also. Okay? So, any doubts with respect to these things? Okay? So, if you have understood, if you don't have any doubts, so we will go with some of the namings of these number molecules, aromatic compounds. Okay then. So I will write one of the molecule. I will write one of the molecule. I have written some of them here. CH2, CH, Cl, CH2, CH, Br, CH2, CH3. Okay. So now this molecule is there. How to name the molecule? How to name the molecule? If I want to write the line structure, then benzene no change, it will be like this only. Okay? So here we have the chlorine, then here we have the bromine. So this will give the line structure. Which will be the parental molecule? Which one will be the parental molecule? Just tell me the parental molecule. Anyone? Any one of you? Okay. Okay. Benzyl, hexane. Okay, Ashish and Gauri. I will go with hexane. I will use this one as a substituent. I will use this one as a substituent because linear structure I have 6 carbon. 2, 3, 4, 5, 6. Okay. So in that case, now how to write the name of the molecule? How to write the name of the molecule? Just tell me first molecule. Okay, some of you have written benzyl. So instead of taking the benzyl, I will go with the linear structure, that is 6 carbon. Okay, where I will use phenyl group as a substituent. Okay. Because linear structure only I am having 6 carbon. Due to that I will go with the phenyl group as a substituent. So now name of the molecule should start with Now least sum rule we have followed. Now we have to name the molecule. We have followed this least sum rule. So 1, 2 and 4. That's where I am going to get the least sum with respect to the substituent. 1, 2 and 4. Now I have to name the molecule. What I should do? Now observe it carefully. When I am naming the molecule, first I should take alphabets. First I should take alphabets. Therefore, I will write it as 4-bromo because B comes first. 4-bromo. Okay, someone else had written, I think. Okay. So that's what Shashank. While writing, alphabets should come first. So 4-bromo. Then 2-chloro. 2-chloro. 1-phenyl. 1-phenyl hexane. 1-phenyl hexane. You have to write like this only. First, if you write 1-phenyl 2-chloro, although numbering is done properly, but since you have written in a wrong way, alphabetical, this one you have not given the importance, therefore you are going to lose the marks. You are going to lose the marks. All of you have understood? Okay? Fine. So this is where we have the molecule. Then we will go with another example. We will go with another example. So another example will be, okay. Then we have CH3. CH3. Fine. Anyone? No long chains are present here. No long chains are present here. So what I should do? Okay. So now when I am numbering this particular thing, okay, so we have Cl, OCH3, then we have the CH3. Now some students, okay, alphabetically chloro, this is methoxy, right? This is chloro and this is methyl. So they think that, oh, okay, chloro alphabetically comes 1, 2, 3, 4, 5, 6. So that's how they are going to give the numbering. This is actually wrong. This is actually wrong because if I add this 1, 2 and 5, 1 plus 2 plus 5. Total it will be 8. So total it will be 8. Now, some students, anyway sir, whatever happens, we have to go with alphabetical preference. So therefore, they will write like this: 1, 2, 3, 4, 5, 6. Now if I add 1 plus 3 plus 6, then 10. It will become 10. So this is also wrong. Why? Because if I number from here 1, 2, 3, 4, 5, 6. If I number like this, I am going to get the least value, least sum rule. 1 plus 2 plus 4. 7. I am going to get the least number. I cannot even start from here, because even if I start from here, I am going to get the largest value. For example, OCH3, Cl, CH3. I have to draw this one bit larger, inner circle. Okay, so 1, 2, 3, 4, 5, 6. So 1 plus 3 plus 4. It will be 8. Wrong. Okay, so this is the only option. So now 2-chloro-4-methyl 1-methoxyhexane. ಗುರುಗಳೇ, ಹೆಕ್ಸೇನ್ ಯಾಕಾಗುತ್ತೆ ಮೇಡಮ್? Why hexane? It's not a hexane. It's not a hexane. Okay? It is a benzene. If you want to use that one as a parental molecule, it should be a benzene, not hexane. Okay now? So now, if I want to write a numbering, or you have written proper name, but parental molecule itself you have written wrong. Go. Okay? So no need to delete. It's fine. It's fine. So now that's where we have the name of the molecule as Gauri she has written. First we should write alphabets. 2-chloro. Okay? So 2-chloro. Then 4-methyl. 4-methyl methoxybenzene. Okay? So 4-methyl methoxybenzene. Methoxybenzene. Or we can call it as anisole. We can call it as anisole. All of you have understood? So 2-chloro, 4-methyl anisole. That is also fine. Wrong is not for this. This wrong is for that particular number. Okay, now even we can call it as or 2-chloro 4-methyl anisole. That is also fine. Both are correct. Both are correct. Fine? All of you have understood? Any doubts? So why have written benzene, methoxybenzene? Because alkoxy group as a substance. Alkoxy group as a substance. So therefore they should be used as a prefix. So therefore methoxybenzene. Okay, methoxybenzene, alkoxy group, halogen and alkyl group. All of them they can be used as a suffix, prefix, not as a suffix. So therefore methoxybenzene. Okay, all of you have understood? Any doubts? Okay, any doubts with respect to this one? Now, if I want to go with another one, NO2, then bromine. Okay, I will use this one. Bromine write here. Then CH3. Okay. So how to write? How to write? Now, we can write this molecule as usual, least some rule. So 1, 2, 3, 4, 5, 6. Least some rule. That's how I have numbered it. 1, 2, 3, 4, 5, 6. Okay? So if I add, I am going to get 1 plus 2 plus 4. 7 I am getting. Okay? So other way around if I number it. Other way around if I number it. NO2, Br, then CH3. Other way around. 1, 2, 3, 4, 5, 6. Then I am going to get 1 plus 2 plus 5. It will become 8. This is wrong. Wrong number. Okay. Same way I will use another one. NO2, Br, CH3. If I start from here, 1, 2, 3, 4, 5, 6. So in that case, 1 plus 3 plus 4. Then 8. So least number rule it will be followed. So this is also wrong. This is also wrong. So numbering has to be done like this. Okay, numbering has to be done like this. Fine. So if that is the case, now we have to name the molecule. Any one of you? Now I want to name the molecule. Any one of you can tell me name of the molecule? Any one of you can tell me the name of the molecule? Anyone? Any one of you? Okay, I can name the molecule as, I should start from alphabets. So 2-bromo, B comes first. 2-bromo, right? Then 1-methyl, 1-methyl, 4-nitro, benzene. Benzene. If I want to take benzene as a parental molecule, all of them as a substituent. So 2-bromo, 1-methyl, LMN, N comes afterwards. So 2-bromo, 1-methyl, 4-nitrobenzene. Okay? Or I can simply write it as 2-bromo, 4-nitro, toluene. Toluene, that is also fine. So toluene, that is also fine. Okay? So yes, Gauri, 2-bromo, 1-methyl, 4-nitrobenzene. Absolutely correct. Absolutely correct. Even we can take the parental molecule as toluene. As earlier we have taken anisole, here also we can take parental molecule as toluene. So any one of these two we can write. Both are correct answers. Both are correct answers. Okay, so while naming the molecule, alphabets. While naming the molecule, alphabets, whatever its number might be. It can be a largest number. Still we have to go with the alphabets while naming the molecules. Fine. So like that we have to name the molecules. We have to write the IUPAC nomenclature for the given molecules. All of you have understood? Fine. Anyway, so tomorrow and the day after tomorrow, once again, I think you people are going with some more examples with respect to IUPAC nomenclature. Now we are going with the classification of a given molecule, that is based on the isomerism. So we are going to discuss about one of the condition called as isomerism. Bit important. Okay, very important. Isomerism. When I am talking about isomerism, this is going to deal with the isomers. So what do you mean by isomers? Isomers are those group of organic compounds having same molecular formula, but differs in their structure. Therefore, since they differs in their structure, to some extent even they differs in their properties also. So they differs in their structures. Okay, so they are called as isomers. So what do you mean by isomers? That is group of organic compounds having same molecular formula but differs in their structure. Okay, so that's where we have the isomers. Isomerism is going to deal with these particular isomers. That's where we have the isomerism, which deals with the study of the isomers. Okay. Now, when I am talking about isomers or isomerism, we can classify them as structural isomerism and stereoisomerism. So structural isomerism is, in the name itself, it is that which differs with respect to the structure. But stereoisomerism means which differs with respect to arrangement of these elements around the carbon. They differs. Okay. So anyway, stereoisomerism we are not going to discuss in detail. Now, in stereoisomerism, once again we have two types: optical isomerism and geometric isomerism. In stereoisomerism, don't worry, we are not going to discuss in detail. So optical isomerism and geometrical isomerism. However, when I am talking about geometrical isomerism, naturally it differs with respect to the geometry. Okay, and optical isomerism with respect to optical property, rotation of light. Please say, okay, we will not going to discuss that one. I will come back to this one. Structural isomerism. In that we have different categories. One is chain isomerism. Okay. So next one is positional isomerism. In this they will ask positional isomerism. In structural isomerism they will ask questions. So positional isomerism. Then we have functional group isomerism. Then we have the functional group isomerism. And finally we have metamerism. Finally, we have the metamerism. Okay, all of you have understood? Chain isomerism, positional isomerism, functional group isomerism, and metamerism. Fine. So, ಹಾಗಾದ್ರೆ isomerism can be classified into stereoisomerism and structural isomerism. ಓಕೆನಾ? ಏನೋ ಸರ್ ಇಷ್ಟು ದಿವಸ ಆರಾಮಾಗಿದ್ವಿ 3 days, ಈಗ ಒಂದೇ ಸರ್ತಿ ಬಂದು ಮೊಳೆ ಹೊಡಿತಾ ಇದ್ದೀರಾ. ಓಕೆನಾ? ಸೊ ಫೈನ್. ಸೊ ಐಸೋಮೆರಿಸಮ್ is going to deal with the isomers. ಹಾಗಾದರೆ isomerism is structural isomerism and stereoisomerism. Structural isomerism with respect to structure, but stereoisomerism with respect to arrangement of these elements around the carbon, because carbon is a tetravalent in nature, right? So it will be having tetrahedral structure. So how those elements will be arranged around the carbon, that's where it is going to deal with the stereoisomerism. Anyway, stereoisomerism, for time being we are not going to discuss, that is not there in your this one. We are going to focus on structural isomerism, where you can expect the questions asked. So in structural isomerism also we have chain isomerism, positional isomerism, functional group isomerism, and metamerism. Okay, all of you have understood? Any doubts? So this is with respect to classification of organic compounds based on the isomerism. So this is with respect to classification of a given organic compound based on its isomerism. Okay na? So I will stop here. Any doubts? So please practice some more examples. Okay, please practice some more examples with respect to IPAC nomenclature and all. Okay, and when we have more than one substance, then you should use di, tri, like that. That word should come with respect to number of same substance. Say for example, if I have 2 chlorine, then dichloro. If I have 2 alcohol, then it should be diol. Dicarboxylic acid, if I have 2 carboxylic acid, like that, appropriate word should come. Okay na? Okay, then I will stop here. Thank you, take care, fine, and practice. Thank you.